It's one of the most ancient life forms on our entire planet. And yeah, you probably just dismiss it as, pond scum or seaweed. But what if I told you this humble little organism has a hidden superpower? Well, that's what we're about to uncover.
Okay, do me a favor. Take a deep breath. Go on, really. Over half of the oxygen you just breathed in, it didn't come from trees. Nope, it came from algae. This tiny, tiny organism is a planetary powerhouse, and honestly, most of us have no idea. So let's really pull back the curtain on this unsung hero, shall we? We're going to dig into how it works, what it's truly capable of, and, why it just might be one of the most important resources for all of our futures.
All right, first things first. Not all algae is created equal. On one side, you've got microalgae. Think microscopic, single-celled little guys. They're basically the foundation of all aquatic food chains. Then you've got the big stuff, macroalgae. We're talking about seaweed, right? Like the giant kelp forests in the ocean, or even the nori that's wrapped around your sushi. Both are super, super important.
So, with all this potential, it's no surprise that a lot of people are calling algae the ultimate wonder crop. But is the hype for real? Is it justified? Well, let's dive in and look at the evidence. Okay, so here's the thing. Algae completely rewrites the rules of farming as we know it. I mean, its productivity is it's off the charts. Some types can literally double their mass in a single hour. It's also ridiculously efficient because it doesn't waste any energy on things like roots or stems. And get this, it can produce up to 100 times more oil per acre than plants on land. But maybe the most important part? It's just so versatile. It can grow in salt water, even polluted water. That means it's not competing with our food crops for precious land or fresh water. That's huge.
So, what can we actually do with all this stuff? Well, for starters, we can eat it. It can be food. When it's dried, microalgae can be up to 60% protein. That's actually higher than soybeans. So it's a potential super source of protein for us, for livestock, and for fish.
And it doesn't stop there. It can also be fertilizer. Yep, algae-based biofertilizers are already out there, helping millions of farmers cut down their chemical use by as much as 20%. It just enriches the soil all naturally.
And then there's the big one, the one everyone's talking about. It can be fuel. The oils inside algae can be converted into biodiesel, ethanol, even jet fuel. I mean, think about that. We're talking about a renewable fuel source that could directly replace the fossil fuels we're so dependent on today.
And if you want to see just how massive that potential is, you got to look at the numbers. Per acre, corn gives you about, 28 gallons of fuel? Palm oil, which is a leading biofuel source, gets you 600. Okay, now look at algae, a staggering 5,000 gallons. Let that sink in. That's not a small step up. That is a complete and total game changer.
Okay, so that's all the potential. It sounds amazing, right? But is anyone actually doing this right now, today? Let's take a look at how this is being applied out there in the real world.
So check this out. There's this company in Scotland. What they do is they take the nutrient-rich wastewater from a whiskey distillery, stuff that would normally just be thrown away, and they use it to grow microalgae. That algae then gets harvested to create omega-3s for fish farms, which means we don't need to catch as many wild fish. And in the process, the wastewater gets cleaned. It's a perfect, totally self-contained loop. Just brilliant. And this is just one example. Similar models are popping up for everything from bioplastics to cosmetics.
Now, with success stories like that, you're probably asking yourself a very big, very obvious question. A question that is, quite literally, a billion-dollar problem. Right? If algae is this miracle solution, then why aren't our cars, our planes, and our farms already running on it? The simple answer, well, it has always boiled down to one thing: cost.
And you know what? The market is still totally torn on this. I mean, look at this. In 2022, ExxonMobil pulled the plug on its 14-year algae research project. But then, just 1 year later, you've got major players like Bill Gates and Chevron investing millions into a new algae company. It just goes to show you how high the stakes and the uncertainty really are.
When this research first got going, the numbers were, they were tough. The projected cost to produce just 1 gallon of algae biofuel was around $30. And at that price, come on, it was never going to compete with fossil fuels. No way.
But thanks to hundreds of innovations in things like genetic engineering and way more efficient harvesting, researchers have brought that projected cost crashing down. We're now looking at a range of maybe $2 to $3 a gallon. And all of a sudden, this isn't science fiction anymore. This is a commercially viable reality.
So the big question is,
How on earth did they get the cost down so dramatically? The key wasn't just about making one part of the process cheaper. The real breakthrough came from rethinking the entire system, and it's all about something called the circular solution. So what is a circular process? Well, it's a system where there's basically no such thing as waste. The output from one process, say CO2 from a power plant or nutrients in sewage, it becomes the valuable input for the next one. It's a completely self-sustaining loop.
And this, right here, is where algae truly, truly shines. Just imagine this for a second. You use algae to treat a city's wastewater. At the exact same time, you're feeding that algae with captured CO2 from a nearby power plant. Then, you harvest all that algae and you turn it into clean fuel or organic fertilizer. What just happened? You just solved like 3 or 4 massive problems all at once.
And that right there, that is the real takeaway. Algae's true power isn't about solving just one problem. It's in its incredible, unique ability to connect our biggest challenges. We're talking energy, waste, pollution, and weave them all together into a single, elegant solution.
It kind of leaves you with this staggering thought, doesn't it? For generations, we've looked at pond scum as something gross, something to be cleaned up. But what if? What if the solution to the world's biggest problems has been right here, all along, hidden inside its smallest, most ancient plant?